Welcome to day two of the applied digitalization for oil and gas. Today we are going to talk about the oil and gas as a system, and we're gonna take a look at the value that we are trying to bring through digital transformation technologies for multiple aspects of the business, including health, safety, security, and environment. We're also going to look at the cultural and behavioral aspects, the generational gap impact on digital transformation, and we're going to highlight machine learning and artificial intelligence and how they are applied to the oil and gas industry. When we look at the oil and gas industry, we are basically looking at a system with multiple components. The science and technology aspects of it, which is a technology intensive business that is driven by economics and finances, as well as it's being regulated by the government and other relevant authorities with direct impact on the society and public image. If we look at the world's critical infrastructure, we see the oil and gas on the list among other critical industries. When we speak about digitalization for the oil and gas, we have to look at it through the eyes of a system because it is a system industry. First, it's considered as a critical infrastructure that is connected to the function of the country where it is located and its economy. We see it on the security headlines, for example, some attacks on the pipelines. The oil and gas supply chain, as discussed in day one, is the world's largest with multiple functions, with multiple goals and vulnerabilities. The oil and gas industry has its own complex threats that are specific to each domain, and it requires dynamic training because of the evolving technologies and the evolving threats and the nature of the business of the oil and gas. When we introduce digital transformation technologies, we have multiple objectives, and some of the values include condition monitoring for efficiency of the operation and real-time decisions. Also, the detection of any operational anomalies and predict it in proactive mode as opposed to reactive, and enable barrier management to control any incidents and give context to the data to make it of a greater value, as well as pattern and trend identification and predictive maintenance to extend the life of the assets and equipment, as well as make the most use of the capital investment. As far as health and safety, security, and environment, it's essential to evaluate the existing capabilities and involve performance strategy that should include all parts of the organization and multiple aspects of it. And the digitalization program should evaluate the operational processes before integrating them into the data and the digital workflows. And always, change management is an integral part of digitalization for health, safety, and environment to enable agility and the flexibility to make changes on the go. Also, it needs to account for the human interaction with the digital interface to enable the sought after value and reap the rewards. And in order to achieve that, you need to measure success. If you can measure it, you can improve it. And this will include developing specific KPIs to keep an eye on things and how they are progressing. This is a survey that was done about the value of digitalization. We can see here it improves the day-to-day operations, help in reducing cost, health, safety, and environment, and the list goes on. The organizational and behavioral aspects are integral part of the digital transformation journey. The use of collaborative environments, as we can see here, can bring multiple subject matter experts through remote work environment to be able to give insights about the application of multiple technologies and do all of this remotely through collaborative environment. Also, the use of drones to replace a human in harsh working environments will allow for more and more remote control. And the virtual reality and augmented reality will help in the expert and the specialized supervision remotely, real-time mode. We can see the impact of Generation Y that appreciates connectivity and shared economy. They tend to bring this to the workplace. Therefore, organizations need to prepare the infrastructure for this untethered society and address this generational gap and prepare for such tensions that are bound to materialize. We can also see here that the pilots, the digital pilots, fail not only due to lack of digital technologies, but rather organizational culture change. And therefore, it's essential to account for these changing workflows and organizational and behavioral aspects to ensure a successful pilots and rollout of digital transformation. This is an exercise about training the workforce for the fourth industrial revolution. You need to look at your existing workforce competency and what are the requirements for the future workforce competency and the levels of education that you need to include, be it early in the education or high school and college education or at the professional level. Who are the stakeholders for your training and educational programs? Government, the companies, the academia. You need to bring all of these together to the table and carry out an exercise to help leverage the competency of your workforce in light of the emerging skills to enable upskilling and reskilling. This slide addresses about artificial intelligence, which are basically programs that behave externally like a human. They have intelligence, human intelligence, but that is artificially introduced. And they can do this both externally and internally. And they require computational systems that can do the algorithms to behave intelligently and carry out logical and rational behaviors. Artificial intelligence gives intelligence to your operations, your equipment. However, no machine has the same levels of intelligence as a human. However, they are good at repetitive tasks. In fact, they eliminate human error and human bias, which makes them very suitable for operational artificial intelligence. Some of the applications of artificial intelligence in oil and gas is the autonomous planning and the scheduling of tasks. We can see how successful they are in beating the chess championship, as well as another applications include steering for a driverless car, and the understanding of the multiple languages used, and the use as robotic assistant or personal assistants in surgery, as well as the daily life, and their application in the stock market to generate profits. And an example for the oil and gas is the corrosion prediction to extend the life of the metals by preventing corrosion. Machine learning are used for artificial intelligence application. There are three main categories: the supervised learning, unsupervised learning, and reinforcement learning. And all of these can be evaluated, and the appropriate category is selected for the specific application. This is an example of machine learning approaches for anomaly detection in the networks. And this is the use for drilling, logging while drilling, and measurement while drilling to detect a kick or abrupt flow of hydrocarbons during drilling operations. The machine learning can be deployed to predict it and take the appropriate action to help in smooth operation for the oil and gas. Regarding that case, the motivation is basically to develop a method to determine the fluid influx, and it does not require any additional information. It uses the existing well logging instrumentation, as can be seen in this figure. As we know that blowouts and kicks are major challenge for oil and gas companies and drilling operations. This table shows some statistics about blowouts and the risks. And this shows a kick, and these are the primary indicators for a kick, which are lagging, and this is the traditional method. And this shows the causes: either the mud weight is lower than required, or the mud weight is during tripping, or the vacuum effect during tripping, or the losses during drilling. And the application of the machine learning model uses these input parameters and the data required for the wells, which are used to train the model and learn the machine. And the use of data science is manifested here through the use of decision tree to classify the data, and the use of multifold cross to validate the model and test the model to predict the fluid influx. These are the required data, which are measurement while drilling and logging while drilling. And these are the data. So the challenges that was faced in building the machine learning model to predict fluid flow and influx is that the data is in a numeric digital format and not scanned images, which is the requirement. The information about fluid influx is not easy, in fact, to retrieve from the paper format and the daily morning report. This is a summary of the machine learning project that we carried out for fluid influx prediction. It was used to predict the kick and deduct it earlier as opposed to lagging ways. It has proven the capability of machine learning models to detect the kicks, and it can be developed for real-time kick monitoring for multiple fields based on the input parameters from the field to capture valuable information and tag the data prior to the development of the model, which is an important exercise. And as we know, the data privacy and the proprietary reason makes it very hard to acquire the data from the industry to develop such data-based machine learning. This is an exercise for machine learning and artificial intelligence. You can think of an application area for machine learning and artificial intelligence in your operation. You state your problem, the motivation why you need to introduce artificial intelligence and machine learning, and what is your proposal and the work plan and the details. And in doing so, you can consider partnering with others instead of doing it all by yourself to help build some alliances with the industry. This concludes day 2.